When a new atom is discovered, you get to name it. And at one point, the atoms were being named after the planets. So there was Uranus, which is the Greek god of the underworld? I think so. Uranus was used to name uranium. So the uranium element was discovered, well, over 100 years ago. And then people started looking for its use. Now, uranium is one of the elements in the periodic table that breaks apart. Breaking apart with radioactivity, breaking apart is called fission. Fission gives out some energy. Every time an atom of uranium breaks apart, you get a little bit of energy. But atoms are very, very small. And so all you need is an amount this big, as big as a melon. And rather than getting lots of little pieces of energy, all the energy at the same time gives you a nuclear bomb. Nuclear bombs were named because of the nucleus. The nucleus is the center of the atom. Nuclear bombs have their energy comes from the center of the atom. Now, there are two main types of uranium. The two types of uranium both have the same number of protons but different numbers of electrons. They're isotopes. Iso, as in isosceles triangles and isobars for the weatherman. Iso means the same. Isotopes have the same number of protons. So they act the same chemically, but uranium-235 and 237 have got different masses. More neutrons in uranium-237. Uranium-235, though, is the unstable one, and that's the one you need for nuclear bombs. Now, it was Einstein that came up with E equals mc squared. Einstein meaning Mr. One Stein? Mr. One Stone. Einstein. Mr. Einstein came up with the equation E equals mc squared for energy is the amount of mass times the speed of light squared. The speed of light is 3 with 8 zeros. When you square that, you get 9 with 16 zeros. So 1 kilogram mass lost gives you 9 with 16 zeros. Oh, sorry. You get 9 with 16 zeros worth of joules of energy. Lots of energy. Most of that energy, most of that energy comes out as kinetic energy. Kinetic energy is movement energy. That's all the wind that comes, and also lots of the heat, because heat is atoms jiggling around and moving. It's their movement energy. So at the end of the Second World War, 1945, when Japan was putting up a great defense, lots of people were dying. Lots of American troops were dying taking the islands that Japan had taken off other people. And so America had the technology of the nuclear bomb, and they first used a uranium bomb on Hiroshima, or Hiroshima, two pronunciations, same city. Hiroshima, they dropped the nuclear bomb, flattened the city. The kinetic energy of the wind flattened buildings. There was a few left standing. Also, when you have a nuclear bomb going off, you get lots of gamma rays. Gamma rays. Gamma rays. And alpha particles and beta particles. A whole load of subatomic particles goes on. But it's the gamma rays that go through the buildings, through the air, and they cause all the cancers in the future. The first bomb didn't have the desired effect. The Emperor of Japan just went, well, I don't think, but he didn't send out treaties and people and phone up America and say, hey, we give up. So the Americans got, a few days later, to drop their second bomb, which meant they got to try the second type of bomb. The first bomb was uranium bomb, the second bomb, from another element, a man-made element this time, named after Pluto, because Pluto was a planet back then. Plutonium can be made from uranium. It's a man-made element. You can't get it out of rocks and stuff. You use uranium to make plutonium, and so they dropped the plutonium atomic bomb on Nagasaki. Nagasaki. And with 2 atomic bombs, the Japanese surrendered. And that was the end of the biggest war in the last 100 years. It was a way to finish it.